Okay, so here we are with our mini tube, and I've drawn it twice here. Look, the actual tube map, and then I've drawn it again on the right there in order that I can just relabel the nodes. So Bond Street would be 1, Green Park 2, etc., etc. And what I'm going to do, this allows me to introduce this notation. Let Pi be the probability, okay, that starting the journey at node I, where I will be 1, 2, 3, or 4, that I reach node 1 before node 2. Okay? So we just found numerically that P3, which is the probability of reaching node 1, Bond Street, before node 2, Green Park, starting at Piccadilly Circus, we found that was about 0.2 numerically speaking, and P4 we found to be approximately 0.4. So this is all numerics. Okay. Here's an observation though. What's P1? That's by definition the probability that I reach Bond Street before Green Park if I start at Bond Street. Well, isn't that 1? Because there's absolute certainty that that will happen because I'm already there. What about P2? P2 is the probability that I reach Bond Street, node 1, before node 2, Green Park, given that I'm already at node 2. There's no way that I can reach Bond Street first because I'm already at Green Park. Okay. But what about P3 and P4? How could we work out that we expect to get those numbers? Okay, theoretically speaking. Well, here's just a basic probability law. Probability law. Okay. Let's just suppose that only one of 2 events, F and G, can occur, and let E be another event. Okay? So there's F and G, but only one of F and G can occur, and E is some other event. Then the probability, I'm just using P for capital P for probability, as often the case in probability theory. You probably see that You'll see that in your other courses. What's the probability of event E happening? Well, given that only F or G can happen, isn't it true that it's the probability that F happens multiplied by the probability of E given F plus the probability of that G happens times the probability of E given that G has happened. It's very natural, right? If there's 2 things F and G that can happen, then if the eventual event E has to happen, then you can either go to F and then let E happen, or go to G and let E happen. Basic probability. Okay, so let's just think about, let's call this P3, okay, which is the probability of reaching Bond Street before Green Park, starting at node 3, which is Piccadilly Circus. Now you can see that if I'm at Piccadilly Circus, I go on the journey, right? But there's only 2 things that can happen. I can either go to Green Park or to Oxford Circus, and I do each of those things with equal probability a half. So in other words, isn't this let F be going to, say, Green Park? The probability of going to Green Park is a half. And then I multiply that by the probability of reaching Bond Street before Green Park, given that I'm at Green Park. That would be P2, by definition. And then let's let G set be that I go to Oxford Circus. Well, I do that with probability a half, and then you can see that the probability that I reach Bond Street before Green Park, given that I'm at Oxford Circus is precisely what I mean by P4. Okay? Okay, let's give myself a little bit more space here. Similarly, can you not see that P4, which is the probability that I reach Bond Street before Green Park, starting at node 4, you see I've got a third chance of going to node 1, which is P1, right? So I've got a third of a chance of going to node 1, and then P1 is the probability of reaching Bond Street before Green Park starting at node 1, plus a third probability, and then P2 plus a third P3. Okay, because I've got 1/3 chance of going to, from node 4, going to either 1, 2, or 3, and then I just multiply by the P1, P2, P3, because that's the probability of event E from any of those stations. But now, I've got two equations, let's call them 1 and 2, and these two conditions here, okay, which give me the values of P1 and P2. So I've essentially got 4 equations for 4 unknowns. So I should be able to solve these equations. And in fact, I'll just tell you that if you just manipulate these, you can, using these, the starred P1 is 1 and P2 is 0, you can actually get the following two simplified equations, and then you can just solve these very simply by hand and find that P3 is 1/5 and P4 is 2/5. It's very, very easy. Okay, 4 equations for 4 unknowns. 2 of them are given explicitly. P1 is 1, P2 is 0. And as you can see, if I just stare up at what I found numerically using the MATLAB simulations, you can see that P3 is indeed 1/5, 0.2 is 1/5, and 2/5 is 0.4, so P4 is approximately that. Okay, so the numerics and the little calculations I've done here based on simple probability theory are indeed consistent. So we've made progress, and in fact, isn't it amazing? We've learned some important things here about working out probabilities, the hitting probabilities, when I do these kind of random journeys on graphs. And we'll look into this some more next.